Hello and welcome. Today I would like us to look at the impact of parental involvement, learning style and grade level on students' attitude towards science. So this is a three-way ANOVA, or what we also know as Factorial ANOVA. So what informs today's study is that we want to know the impact of the three independent variables: parental involvement, learning styles, and grade level influence students' attitude towards science, contributing to strategies for increasing STEM interest. So if you look at the SPSS file that I already have here, you will see that the independent variables, that is parental involvement, learning style, and grade level, that they are into three different groups: low, moderate, and high. Learning style, visual, auditory, kinesthetic. Then grade level, elementary, middle school, high school. And the dependent variable, which was measured using a standardized attitude scale, is presented on continuous variable. So this is continuous. And then while the independent variables are categorical. So the Factorial ANOVA is conducted when you have up to three independent variables in your study with a continuous dependent variable. Okay, so I've done other previous videos where I've explained what to do supposing you used a Likert scale. So you may want to group the response, the item statements to have a continuous variable. So you can check out my previous video on how to do that. Now, before we go into the analysis, I'd like us to look at some key importance of three-way ANOVA in research. So the first is that it enables the simultaneous analysis of three independent variables and their interactions, providing a comprehensive understanding of their individual and combined effects on a dependent variable. Okay, so in this case, you have three independent variables and one dependent variable, and then you want to know the effects and at the same time the interaction effects on the dependent variable, which must be a continuous variable this time. And so it helps in identifying the main effects. So this highlights the individual influence of each factor on the dependent variable. 2, it explores interactions. So it unveils how variables interact, offering insights into complex relationships. 3, it enhances efficacy, so it reduces the need for multiple separate analyses, saving time and resources. And I must explain to you that three-way ANOVA or Factorial ANOVA is a very rigorous and complex analysis, and you must have to be careful when conducting this study because of the nature of the rigor in it. Then it increases accuracy, so it controls for confounding variables by analyzing their interactions in one model simultaneously. Okay. And then lastly, it informs decision making, so it guides practical interventions by pinpointing influential factors and their synergy. We can summarize by saying that the three-way ANOVA has the following, the main effects, so which has three hypotheses, one for each independent variable, and then two-way interactions, three hypotheses for each pairwise interaction. As we go deeper into the analysis, you'll be able to understand how we come about this. So I encourage you to watch the tutorial to the end so you'll be able to understand how to perform this analysis yourself. Then three-way interaction, which is one hypothesis. So I'm going to show you these hypotheses, and then you'll be able to understand that. Then total. So you're likely going to have 7 hypotheses for testing in the three-way ANOVA. So these are the main effect hypotheses. One, the main effect of parental involvement. So you have the null hypothesis and then the alternate hypothesis. Okay, so the null hypothesis that the parental involvement, which includes low, moderate, and high level of involvement, has no significant effect on students' attitude towards science, and that will also the opposite of these will be the alternative hypothesis. So effect on learning style. So you also have the null and alternative, and then the effect of grade level. So these are the main effects, okay, the main effect hypothesis. So now you can see that we have 1, 2, and 3, and that leads us to the interaction effects hypothesis. So you have the first interaction is the interaction between parental involvement and learning style. So this can be in other contexts. For example, if you're in pure sciences, maybe in chemistry, physics, in health, or in business. So this can be your own variable. So the interaction between parental involvement and learning style. So this is the null hypothesis and also the alternate. That is a significant interaction effect between parental involvement and learning styles on students' attitude towards science. The other one is the interaction between parental involvement and grade level. So pay key attention here, because when I'll perform the analysis in SPSS, you'll be able to understand how I perform the analysis to create the interactions between these independent variables. The next one is the interaction between learning style and grade level. And then lastly, the three-way interaction. That is parental involvement, learning style, and grade level. Now, but there are 6 basic assumptions of three-way ANOVA that I would like us to quickly look at before we can proceed to run the analysis. Having understood that we need to present 7 hypotheses once we want to do a factorial three-way ANOVA analysis. So number 1 is the independence of observation. So each observation must be independent of others. This means there should be no correlation between the responses of different participants or data points. Number 2 is normality. So the dependent variable should be approximately normally distributed within each group defined by the combination of the independent variable level. This can be tested using normality tests like the Shapiro-Wilk test. So you can check out my previous video on how to conduct normality tests. Only the dependent variable should be subjected to normality tests so that you be sure that it is normally distributed before you can proceed to conduct your three-way ANOVA. Now, if the dependent variable is not normally distributed, then you may have to stop the analysis or try log function to see whether you can put the dependent variable to be normally distributed. The third important assumption is homogeneity of variances. The variance of the dependent variable should be equal across all groups. This can be tested using the Levene's test or Bartlett's test. So when performing this analysis in SPSS, I will check the homogeneity of variances test. And this can enable us to know whether we should continue the analysis or we should stop the analysis of violating the assumption of ANOVA, three-way ANOVA. Then lastly is the continuous dependent variable. The dependent variable must be measured on an interval or ratio scale. The categorical independent variable. So the independent variables must be categorical. What do I mean by categorical? Just like I showed in the SPSS, you have the low, medium, high, okay? With each variable having 2 or more levels. For example, if we have gender as part of the independent variables, definitely you know that gender is male and female. That is 2 levels. Assuming you say prefer not to say, that means more 3 levels, okay? Like the parental involvement, low level of involvement, medium level of moderate level of involvement, high level of involvement. That is three levels, okay? And then adequate sample size. So a sufficient number of observations in each group is required to ensure the reliability of the result and avoid issues of statistical power. Now, there are key decisions before we go proper into conducting this analysis. We have key decision rules. So we have the benefit, the interpretation of the p-value, okay? Now, if the p-value is less than 0.05, so we can conclude that the independent variable has a significant impact on the dependent variable. And so the post hoc test to perform pairwise comparison, like the Tukey's test, to identify which independent variable levels differ significantly, now becomes important. The two key interactions that we have, if the p-value for the two interactions, for example, parental involvement and learning style, are significant, analyze how the combination of these two impact the dependent variable. The same thing with the three-way, and then you can now use the plot interaction to interpret the measure or the nature of the significant interactions, as interaction effects are better understood visually. So you can use graphs or bar charts or line charts to illustrate how the relationships are faring, okay? So this moment, let us head over to SPSS and then perform the analysis, having had the little background information. The first thing we need to do is to first check the dependent variable to be sure that it is normally distributed. If it is not, then you need to do something about this, okay? So to do that, I will go to Analyze, Descriptive Statistics, Explore, and I will take the dependent variable student's attitude into the dependent variable list. Then I'm going to select the histogram and normality plots, okay? And then I will click OK to see the results of the normality. So first of all, look at that. So we are violating the first rule, the first assumption of three-way ANOVA test. First is the test of normality. You can see the sig value for Shapiro-Wilk test is statistically significant. So when the sig value is not greater than 0.05, it means that this data, the dependent variable data, is not considered normally distributed. Okay, even though the Kolmogorov-Smirnov test is not statistically significant, but the Shapiro-Wilk test is. And if we look at the histogram, this can give us an idea that there's a problem. The data is not considered to be normally distributed. And let's look at it this way. Then I'll add the distribution curve, and well, you can see that you can see some values popping out here and then here. So we may consider these not normally distributed. So the violation of assumption number 1 has been seen. So at this point, this analysis ought to stop. But because this is for the purpose of demonstration, teaching you how to do that, we want to proceed with the analysis. Now, having done that, the first thing we need to do is first check the main effect to see whether there are significant differences in the main effects, and if there are, then we can now conduct the Tukey HSD test to now know the actual effects, the ones contributing significantly to students' attitude towards science. Okay, so to do that, we go to Analyze, General Linear Model, we go to Univariate, and so we put the student attitude into the dependent variable box, and then we select parental, learning, and grade level into fixed factor. And first of all, we want to see the descriptive statistics, and then the effect size. So this gives us the opportunity to know the ones that are actually contributing, whether there is truly any significant result, any significant effect difference between the groups. Okay, whether parental involvement has any significant effect, the same thing, learning style, the same thing, grade level. So we want to see that. Then if there are, then we now go into the next one. Okay, to do that, we will first check. So this is the first between subject factors. So this is like the descriptive statistics. So we have the parental involvement, that is low, 2 equal to moderate, 3 equal to high. So this is like telling us how this was coded into the SPSS. And then we have these are the individuals, the numbers, and the observation. And then the second table is the descriptive statistics, which gives us the total number and their means. Okay, the parental involvement, learning style, grade level. But this is where our interest is, first of all. So we want to be sure here that the test of between subject effects, and we want to look at the seek value here and the partial eta squared results. So first off is parental involvement. So this seek value shows evidence of statistically significant result. And what this tells us is, if the p-value for the main effect, if the p-value for any of the main effects, example, parental involvement, learning style, and grade level, is less than 0.05, conclude that the independent variable has a significant impact on the dependent variable. Then you go for post hoc test to now identify which independent variable levels differ significantly. So now we can see that there's a statistically significant effect of the parental involvement. So what it means is that there is evidence that parental involvement significantly contributes or affect or impact students' attitude. Again, learning styles, we do not have evidence, okay, because this is not statistically significant. So we do not have evidence that learning styles contribute student attitude towards science. Grade level, so this is 0.001, which is less than 0.05, confirming evidence that student grade level significantly influence their attitude towards science. Again, we have the parental involvement and learning style. This is the interaction. The interaction, remember, we have hypothesis 1, 2, 3, 4, 5, 6, and 7. Remember from the previous explanations I gave. Now you can see that the interaction between the interaction of parental involvement and learning styles has a positive effect, contributes to students' attitude towards science, because we have the p-value less than 0.05. So let's also look at that. For the interaction effect, if p-values for two-way interaction, this is a two-way interaction here. So this is parental involvement by learning styles. That is, this asterisk here shows the interaction. This is how you write that. Parental involvement times signifies interaction effect. Okay, so you use multiplication sign to illustrate interaction between two independent variables. So if the p-value is less, so it means that is a combined effect of these two independent variables on the dependent variable. So in this case, it means that when parental involvement mixed with learning styles, it statistically significantly contributes to students' attitude towards science study. And then the same thing also happened here. You can see the parental involvement, when it interacts, when it meets with the student's grade level, we also find that it makes a significant contribution to students' attitude, because this is 0.035, that's lesser than 0.05 statistically significant alpha level. And then you can see the partial eta squared 0.06. You can also see the partial eta squared here. That is like the effect size, okay, which is 0.127. That's about 12.7%. Contribution here is about 17.2% if you want to put it into percentage. But again, the also learning styles interacting with grade level also has a significant effect, because it's also 0.013. okay. And then parental involvement, the three-way interaction, parental involvement, learning styles, and grade level, you can see it is not statistically significant. So having gotten these analyses, what we need to do is to check the Tukey's HSD test. But before we do that, I also want to tell you that one more check that needs to be done is the homogeneity of variance test. So that also will also determine whether we are violating or we are not violating the rules. So to do that, we go back to analyze, general linear model, and then we go to the we go to homogeneity test, and then we check. So if you look at the result here, this is already what we've already got before now, but I want you to look at the homogeneity of equality of error variances. So this is Levin's test. So this result here, you look at the sig value. We are interested in the sig value to be sure that the sig values for all of them are not less than 0.05 significant alpha level. So at this stage, you can see that the study already is violating the rule of ANOVA, and it should stop at this point. But why am I demonstrating this video? Most times the YouTube videos we see are those videos that everything feel all right. So when you want to now run the analysis on your own, you begin to experience some troubles, like not meeting these assumptions. So in this video, I tried to use a data that has issues, so that I want to also tell you that the YouTube tutorials also can use data that are not normally distributed or not meeting the assumptions of ANOVA test. This is just in case if you run into this problem, okay? So you can see that at this point we are violating the Levin's test of equality of error variances at this point. This is exactly the same result that we've got before now, but because this is for the purpose of demonstration, this demonstration will continue, so that you will see how to now understand how each of these individual variables now contribute to the dependent variable student attitude. So to do that, I will still go back to the univariate analysis and then go to the plot, because I want to create the interaction, okay, to check the interaction effect. So to do this, I will first insert the parental involvement. Remember that we've got let me use the following interaction effects: parental involvement and learning style, parental involvement and grade level, parental interaction between learning styles and grade level, and then the three-way interaction. So this is how I'm going to create them right now. So you can insert any of the variables in any of these boxes. That's not a problem. For example, you can have first is parental involvement and learning style. So this is parental involvement in the horizontal, learning style in the separate lines. Okay, then you can also have it this way. I can decide to have this one here and have this one here. Whatever works, they will produce the same result for you. So we create the first interaction and then you add, because that parental involvement and learning styles Then I will create parental involvement and grade level. I will add that the second interaction. The third interaction is learning style and grade level. I will add. The fourth interaction, remember, this is the third one. The fourth one is parental involvement, learning style, and grade level. So parental involvement, learning style, grade level, and I'm gonna put that here. So I've got the 4 interactions. So I can decide to use line chart or bar chart, okay? And then click continue. Then I want to now perform the Tukey's tests. So I will insert these into here and then click on Tukey honesty test. Then I can go to the estimate of means, and then I want to display the means for this and compare mean effects. And then to save, I want to see the unstandardized result if I want, and then I will click continue and click OK. So this produced the results that I want. So at this stage, these are already the results that we've been having before now. But what has changed so far? You can see the result of Leven's test that we already got before. You can see the test of between subject effects, which we now want to use to now begin to see the individual contributions. Okay, so this is the estimated marginal means, and I would like to explain to you that if you want to run 3-way ANOVA test, you need to be extremely careful because it's going to produce a very large number of tables and graphs for you. So you need to do this with the support of an expert. But again, let us see how, first of all, let's go to the test of between subject effects. First, parental involvement significantly contributes to students' attitude, but let us see how it does that. Now, the estimated marginal means gives us an idea. Now, you can see that the mean for the mean effect for the high is 65.2, and then the moderate to 59, and the low. So that gives us an idea that the higher parental involvement, the higher possibility of students' attitude towards science. Okay, this is exactly what this marginal effect, because while this is statistically significant, we do not know which of them, because if you look at the work we've got here, you will see that we have 3 levels. Okay, so the question would be which among them contributes higher. Okay, because we've got 3 levels: low, moderate, and high. So in this case, you can see that we can now confirm that for the parental involvement, those whose parents are highly involved in their academic activities are most likely to have higher attitude towards science. Okay, so you can also look at the pairwise comparison test. So this gives us a kind of an idea of how it contributes parental involvement when it becomes low. Comparing low parental involvement to moderate parental involvement, it is statistically significant. All of them are statistically significant, but that gives a decrease in a lower effect, just like what we've had, what we got here, lower mean for the low. So when you compare low parental involvement to moderate and high, you see that it is positive, it is statistically significant, but quite less. Okay, then when moderate, you can see, looking at the mean values here, the moderate is higher than low. Okay, the mean for the moderate involvement, parental involvement, is higher than that of low. So this now gives us an idea that when the moderate parental involvement, when you compare that to the low level, that's a positive effect. It is higher than low. But when you compare the moderate effect compared to the high level of involvement, it is lesser. But look at the high level of parental involvement when compared to low level that is quite positive, contributing high. Okay, the mean difference is 12.126, okay, when compared to low, and then when compared to moderate parental involvement, it is 5.786, which is giving us evidence that evidence of how the different levels of parental involvement contribute to students' attitude towards science behavior, to attitude towards science. Okay, so that is for parental involvement. The next one is learning style. So this is not statistically significant, so it means that there is no difference, so you don't need to bother much. Then if you look at the mean, if you look at the means here, you will see that both visual, auditory, and kinesthetic, you see that the mean differences are not much, 60, 56, 58, okay? So, and again, none is statistically significant here, showing that we do not have evidence of its contribution or their contributions to student attitude towards science. The next one that we want to look at is grade level. The result shows that grade level contributes positively towards student attitude. So we head over to grade level. So you look at the estimate, and you can see the mean for the grade level. You can see 69.4, 58 for middle school, and then 53.347 for elementary. So when you look at the pairwise comparison, you can see that comparing elementary grade level to middle school level, you have a negative effect, and it's statistically significant. So showing that the grade level of those who are in elementary may likely have lower attitude towards science when compared to those in the middle and high, okay, high school. And then when you compare middle school to elementary and high, you can see that when you compare middle school to elementary, you will see that there's a positive effect there. Of course, they have a higher attitude, to contribute to higher attitude towards science, but when compared to those in high school, it will have a lower effect, okay? It means that they are less when compared to those in high school. And the same thing here, if you look at those in high school when compared to elementary, that's a very high significant difference, okay? And then when also compared to middle school, you can see that it's also positive and significant. Then this is the interaction effect. So we go back again to the main analysis, which is the test between subject effects. And we look at the next one that is statistically significant, is the parental involvement and learning style, which is statistically significant. So we head over to the main effect, that is parental involvement and the learning style. So we can see their level of effects and how they contribute. So kinesthetic contributing higher, the mean is higher than those of visual, auditory, and then for the moderate, you can also see that kinesthetic has a very high mean value, showing that it contributes higher. The same thing when comparing high parental involvement and learning styles, you can also see that kinesthetic also provides a higher level of contribution. The same thing, we also check the one that is also significant, parental involvement and grade level is also statistically significant, showing that the interaction between both of them contributes to attitude towards science. So we also go to that one again, parental and grade level. So you can see that the high level of when the parental level is low, it still contributes. Comparing to those in high school, you have a very high mean. And then the same thing when the parental involvement is moderate, there is a significant effect for middle, but we do not have a statistically significant effect on the high school. So indicating that with moderate effects, even for those in middle school, are most likely to have a higher level of attitude. Okay, for high, level, the analysis shows evidence that for those in middle school and high school, they are contributing more when compared to those in elementary. And the same thing in learning style and grade level. So we have also a significant interaction. Then when you also look at that, you can see the higher means, so you know the ones contributing higher. For example, in this case, the mean is 65.8, showing that when compared, the interaction between learning styles and grade level, the visual, when compared to grade level in the middle school, has a higher contribution than auditory in the middle school, and then at the same time kinesthetic in the high school contribute. But again, in this case, we do not have evidence of significant interaction. When you look at this result here, parental involvement and learning style, so we do not have a statistically significant evidence that this is positive, that this interaction between parental involvement, learning styles, and grade level, which is the three-way interaction, contributes to student attitude. And let me quickly take you to the post hoc test. Okay, this is also what we have before now. It's just like what we have in the pairwise comparison. So this is just exactly the same result that we've gotten here. But let me take you quickly to the interaction of the marginal, the estimated marginal means of student attitude. So this graph here, plot here, also gives you an idea. So you can see the parental involvement. You can see at low level of learning style, which is kinesthetic, the red colored, auditory, and then the visual here, which is this. And then at the average or moderate level of parental involvement, you can see the contribution so far. This is just the same thing that we have seen in the tables. And then when parental involvement is high, you have a higher contribution towards student attitude. The same thing played out here, the same thing here, and then for the three-way interaction where we do not have evidence. So you need to keep an eye on the ones that we have the interaction effects. So where we do not have the evidence of significant result, you do not pay too much attention to explaining them if it is journal article, because we want to see those that are contributing and then how they are contributing significant. This is how you can run the three-way ANOVA, or what we call Factorial ANOVA, and then go on to interpret the results, write it out in Microsoft Word the way I have made these explanations. But again, let me remind you that the key result is this: the test between subject effects. So this is the test that will guide you into whether you are going on to look at the pairwise comparison test and then the interaction, how they contribute to the dependent variable, the change in dependent variable. Okay, so if, for example, you run the analysis and none of these are statistically significant, there is basically no reason for you to go on to conduct the post hoc test, because the post hoc test now enabled us to understand the level at which each of the levels, okay, each of the levels, the three levels, contribute significantly to the dependent variable. I hope you find this video interesting and helpful. Please like and share the video and subscribe to my channel if you've not done so. Thank you so much for watching.